Hey, what are you doing over there? The show started.
All right.
Let's get started.
Back to business, huh?
Yes.
So, actually, for the response for the first episode was pretty.
It was pretty overwhelming, I'm not
Yeah,
gonna lie.
it was positive and negative.
Yeah.
We got a lot of backhanded compliments, by the way.
Oh, right, you were
Like,
telling me.
I don't know. It's like either say it's good or bad. It's like, though for your first episode, we expected it to be cringe and all, but surprisingly, it was good.
Yeah, that's what it ended up. I got a lot like those, dude. I don't know if I'm supposed to be happy or, surprised or what.
What was the best compliment or feedback you got?
Oof. So it wasn't really.
Don't name names, but you know.
Yes. So it wasn't really a compliment, as in it wasn't really like a very well-worded compliment or anything. It was someone that I didn't expect to watch the podcast. Watched the podcast and said that they really, really liked it. Which
Okay.
was super surprising because then I realized that we have a very wide audience and like a lot of people understand what we're saying.
Okay. For me, it was there was one guy in the hostel, and he was he was busy, and I'm like, dude, I released the episode. Just listen. I know you're busy, but just listen to the intro music. That's like 15-20 seconds, and we made it so I want to listen to it. And then I just put on the intro music, the whole episode, and be like, just listen to the intro music, and I went. And the next day, man pulls up and he's like, bro, I like. Remember the time you just put the intro music on? Like, I was listening to the first 5 minutes. It was interesting that I made it throughout the episode. So that's pretty special.
Yeah, that is pretty wild.
And and for the people who picked up on the fact that I ripped off entire video of the Vegetative about the planned obsolescence. Okay, now listen, we had done our research. We had done we had all these darkness statistics and all.
True. When Shreyas approached me for the podcast itself, he had like a lot of stats and
but
a lot
the thing
of
is, like,
dark
right
research.
before the episode we started recording, we're like, though, let me just quickly glance through this video. And like after the final, like after editing and the final episode went out, and when I listened to it, it's exactly the same. The order.
Exactly, the order was what got. It's still, you've learned your lesson now.
Anyway. Yeah, and many people like told me that I can't, and I know this, and they told me that I can't say the words which has R in it.
Right.
And
Say R?
R.
Yeah, that's fine.
I don't know, bro. It's like, I don't know. I feel like it's one of those, it sounds like a small kid with a lollipop in his mouth or something like that.
Right.
R.
It's shit.
R. Yeah.
Even I have like a lot of work because I don't know if you can tell now because I have a cold and my voice sounds very different.
By the way, for people who are telling when is the second episode coming and all, now listen, I got my wisdom tooth removed.
Yeah. I have a horrible cold.
And still we are recording.
Exactly.
Okay, so we do care. So
yes.
It's just that we need to find time.
We care about you people.
Yeah, and we're making this happen. The second episode.
Exactly.
Yeah. So this is a really special episode for us because this would be our first guest episode, and I have my good friend Aniket with me, and we'll be talking about stuff like materialism, hard problem of consciousness, origin of the information, quantum mechanics, free will. So let's start.
Has anyone here heard of the movie They Live?
Yeah, I have.
The one with Roddy Piper in it.
Mm-hmm.
Yeah. So, as the movie goes, the main character, he's just stumbling around New York City, and he finds these glasses.
Okay.
And when he wears them on, he notices that things look a bit different. First, there's no color through the glasses. He can't see the color of the objects around him. And the labels of the text change. So when he sees, let's say, a note, $1 maybe, when he sees that, instead of it reading $1, it reads, "This is your God."
Okay.
And so he starts seeing this underlying nature of reality, which has been clouded by the technology that the enemy was using in the movie, which were a bunch of aliens.
Mm-hmm.
So something similar is going to happen in this episode, where I'm going to remove the saturation,
Okay.
and once you put on these glasses, you're going to see reality in a different way.
And like basically the face value of things, not like what value we gave it.
Yeah.
It's like
what we perceive to be the objective, the so-called objective nature of what we see around us.
cool.
So so what is materialism? Well, this goes back to the Greeks, everything starts there. And they also had a concept of materialism. So what they postulated was that there are everything that exists, that you can perceive, that you can see, can be reducible to atoms in the void. And that was basically the formal beginning of this this worldview or
Of
Weltanschauung.
materialism.
Yeah, of materialism. So
And how does it compare to like nowadays?
yeah, and nowadays we have if the Greeks saw the development of this line of thinking, then they would be shocked, they wouldn't believe it.
Okay.
But we have through this line of reasoning, we have reduced everything about, let's say for example, the brain to chemical reactions and electrical impulses. So if you touch something hot, really hot, it sends an electrical impulse to your brain, and you
Yeah, we
react
can
quickly.
say like the world's not more romantic, It's more like, okay, this is chemical reaction, this is neurons, this is electric signals.
Yeah,
So,
like
but before brain was like, oh, this complex thing where you had to, like think and take a break from your work life to like write a poem, I guess. But now it's just like, I don't know, like, did you listen to the podcast of JRE where Quentin Tarantino was there? And he's like I just go for a quick swim and I'll be recharged. My creative part of my brain is like fresh. It's like a new whiteboard all over again. Something like that.
yeah, it's almost as if the life has been sucked out of life, right? Everything's reduced
Okay.
to machines,
Yeah.
right? We're a machine. We sit inside a machine. That's what the analogy goes, right? So, well, let's explore this, because if one were to hold this view that everything, that the mind originates from the brain, and it's a phenomena that arises out of the movement and chemical reactions that take place when the neurons are firing. So there was this field of, during the development of this line of thinking, there was a field of science that emerged, which is called phrenology. So what classical scientists posited was that if everything that about a personality of a human originated from the brain, so there must be certain parts of the brain that associate to certain personality traits.
Okay.
So for example, everyone's seen the memes where they show like a 2D slice of the brain with maybe music taking up 90% of the brain, studies taking up 2%. So something like that. They were taking it in a very formal way, and they were trying to explore whether this makes sense. So it is called phrenology. And years later, right now, we recognize phrenology as a pseudoscience.
Really?
So we can't really pinpoint that at this part of the brain is where this particular trait of this person exists. So if we remove that part of the brain, the person something should happen to the characteristics of the personality. Speaking of removing a part of your brain, did you know that you can take half of your brain and discard it, and you can still live like a normal life? And what happens when you remove. Fine,
don't
fine.
ask you want to say something or anything.
Fine, fine.
Okay, yeah, so Shreyas got a call there, if you can hear it on the mic. But, so I had, you were mentioning something about cutting half your brain out, and then
Yeah.
that would severely affect your personality. So, in my head, the way I saw the brain working was that as you go through life, your brain builds certain neural pathways based on the circumstances you've been through and the habits you develop and the thought process you develop that you keep going back to. And so what phenology suggests is that for every single person, that one particular part of the brain, if you pinpoint that one particular part of the brain at that exact location, that would affect everyone's personality in the same way. Was that the point of phenology?
Sort of, but what we know now is that even what you're saying right now, that maybe for different individuals, the brain is different. It shapes differently, right?
Right.
So for a musician, there are certain parts of the brain that have more complexity or more neurons firing.
Mm-hmm.
So it turns out it's even more complicated than that.
Oof, okay.
So let's say you take that person.
Yeah.
With that, let's say a musician.
With that particular circumstance.
Yeah.
in that
Let's say
way of
that's.
life, right.
Let's say we take a musician,
Mm-hmm.
and we remove half of the brain.
Mm-hmm.
They don't lose any part of their personality at all.
Oh, what?
Yeah. And there's actually a surgery. It's called corpus callosum.
So these people were both alive after removing half their brain and their personality doesn't change?
It doesn't. In fact, the changes are so minute and subtle that this guy, when he was trying to figure out what exactly changed, it took him his entire life, and he won a Nobel Prize after that.
Wow, okay, for his discovery on his own brain.
Not his own brain, but basically patients who had gone through the surgery.
Okay. Yeah, that is wild.
So the differences are so subtle, all right, that if you were to talk to the person after the surgery, you wouldn't realize that they don't have half their brain.
Wow. Are there any particular cases that you can pinpoint that you really like? That, when someone removes half their brain?
Well, I don't have particular cases, but there was a guy called Sperry, and he really revolutionized this sort of research. So he was a neuroscientist.
Okay.
And so what he did was, there were these patients with severe cases of seizure.
Okay.
So the seizure would start on one of the hemispheres of the brain, and it would travel across the brain into the other hemisphere.
Ooh.
So what he thought of doing was to sever the connection between the two halves of the brain. And so you see there's this hole, all right, the brain, an organ. Imagine if you take your heart, you slice it in two.
Exactly, you're dead.
You're dead. But the brain, if you sever that connection between the two hemispheres,
it just functions normally?
it just functions normally.
Whoa, okay.
Yeah, actually that makes sense. You know why? Because brain is a pretty complicated thing. Let's just see it in real life, okay? Suppose like the power grids in any city. Like a power grid in any city, compare that to a brain. It's not like when there's there's a problem in one grid or one tower, it's not like the whole power grid shuts off. So I think the fact that it's more effective to decentralize the not control, but decentralize functions throughout the brain and not keep one section for this, so that if that's damaged, you're doomed. So it makes sense, when you're creating a complex system as the human body, to decentralize the controlling system that's your brain. Yeah.
Wait, when who's creating?
Oh, when who's creating? So what's
I think you meant from an evolutionary point, right? Like as humans evolved over time, they learned to decentralize their brain function so that they survive better.
Yeah,
I'm sure some saber-toothed tiger must have mauled off some dude's head.
there was this article that I read somewhere where they were looking at the origin of consciousness from an evolutionary point of view. So what the research, what they concluded was that at some point of time, if you assume that humans evolved from non-sentient beings, right? At some point of time, there was no consciousness inside the human brain. And so you would get these, and so from the perspective of the dude, he, he, it would be almost as if there are voices dictating what he should do. And so they had this theory developed that these voices, when the bicameral brain broke down and you had the mind, the consciousness, that these voices then became what people call voices in your head.
Yeah. So you just told that when it was a major event when humans realize that there's a consciousness. It's not just the inner voice that's guiding you, right? Like when you take, for example, like automotive industry, when you date back and you see which was the most important invention or breakthrough that led through the field, like you would say it would be the steam engine or something like that. I feel like in human history, I feel the breaking point or like the most important realization, not invention but realization, is that is that of the consciousness.
Yeah, because that's when we can choose. That's when we could choose
Yeah,
what to do.
basically that told you are in the control seat. It's like you dictate your actions.
And the voices then became these, they became, the id, the super id, the ego, these things that nowadays we consider nuisances.
Yeah.
Before, consciousness would have been dictating our every action.
I mean, we can't really say it's like a bad thing, because there are certain important feelings, I would say, like ego or betrayal or something which would be
Love.
required in which would be required in certain situations. Suppose you're the Viking, you want the sense of, if someone betrayed you, you want the sense of revenge, or you need these human emotions to like in a broader aspect, to just continue your generation. Like at the moment it'll be like, oh, I just need to win this battle. No, you need to win this battle, you need to survive, you need to make kids so that your genes are gone to the next generation. So yeah, these are like important human feelings, which
Yeah, that's why sometimes we listen to them.
sometimes. But I feel like, as time progressed, we, coming back to materialism, whatever favored us getting richer or whatever favored us getting to what we want, and we declared the other feelings as irrelevant or not useful, which would have a negative effect on humans and a broader aspect.
Yeah, that would. And okay, yeah. So yeah, what he said was pretty much made sense. I mean, if you are not listening to these voices that develop through, let's say, the evolutionary processes that selected for us, it obviously made us superior from the people who didn't have these particular sets of voices, let's say. And nowadays, people take them for granted, and they think maybe we can get away with if we just ignore these voices. So there is a balance to be struck between these base instincts and higher order thinking. So coming back to the neuroscience of all of this, along with the origin of the consciousness, would you agree that there would be an origin of free will?
The origin of free will, like in a society sense, like when people have free will, like that, or individual sense, like
No,
for
I
individual.
mean in a very individual sense.
Okay, individual. I'm not sure. I'm not sure what's the origin of free will for the individual.
Well, think of it this way. Imagine a sentient being that you can't really have sentience when you think of it. Let's say you see a person walking by, and you assume they have consciousness, right? Now, what do you actually mean when you say that they are conscious? If I were to ask you, how do you know if something is conscious or not? What would be some factors or points that you would look to?
Yeah, when I wake up without a shirt and look at my fat self, I'm conscious and I'm fat and I need to go to the gym. So I'm conscious about, fine, this is the point. I need to start working on myself. So that's like a parameter for me.
But that's a parameter for you.
Yeah.
So you know if you're conscious or not, right?
Pretty much. In the aspect of physical health.
But how would you know that someone like the person sitting right beside you is conscious of their health?
We can't really tell. I mean, if they are, in a good shape, in a good health, you can like generalize that, yeah, they're conscious about the health.
I don't mean it in that sense. I mean, they might take good care of their health, but is that what they choose to? Is that what they chose to do?
Okay. When you say free will or consciousness, you don't mean with regards to things. You mean the ability where if I decide to wave my hand right now, that my body lets me do it. That's what you mean by consciousness and free
Yeah.
will? Oof. I feel like at this point that's a spectrum, no? I mean, so now as beings evolve, if you look at going by the evolutionary standpoint that you posed before, if you look at like really old, like, I don't know, microorganisms.
Bacteria.
Right. They probably have, let's say, think about it like a computer program. So they'll probably have, like, based on the stuff that they see in the sensors in their eye and things like that, it's more like a very if-else scenario where if this exact combination of things happen, I have to do this. If this exact combination of things happen, I have to do that, etc. And that works when you're like a really tiny microorganism because you don't have stuff like this to deal with. But as we slowly become very conscious beings, like let's say you move into like a tiger, for example, let's say. So a tiger can't just deal with a bunch of if-else statements, right? Because of the fact that every case becomes very complex. And even if one thing is off, it wouldn't be that same case anymore, right? So slowly, I mean, like, for example, let's say this is getting real technical, but I mean, like, let's say it's A is equal to B is equal to 5. Like, A is equal to 1, B is equal to 2, B is equal to 3, C is equal to 3. Then you can maybe have, like, 9 cases with that, right? Where A changes from 1 to 3, B changes from 2 to 3, 1 to 3, and C changes from 1 to 3.
Yeah, many permutations and combinations.
Right. But when you're like a tiger, say, for example, and you're looking at, let's say the deer is right there, and there's, I don't know, like a mammoth on your left and stuff. There's so many different possibilities that could happen, right? So in the end, consciousness evolves as a method of
Choice.
as a method of looking at your situation and having the ability to logically kind of figure out what your own if-else cases are. And so beings that need that more, that have many more cases in their life and many more things to consider, slowly end up feeling more conscious.
Guess what? What he just said was very similar to the definition of free will.
Oh, okay.
Because there is this philosopher who goes by Ayn Rand. She was once asked to define what she means by free will. So she's a libertarian.
Okay.
In every sense. So in the sense of political,
right,
and also philosophical. So she believed that that every being is conscious and in control of their actions. So the definition that she gave for free will was that man's free choices come from focusing his mind. So there can be many variables and factors. And the more variables and factors that you take into consideration for your actions, the better results you get.
Right.
And what you can do is you can choose to avoid focusing on certain variables. And you can even refuse to think. And that's basically what she said is what we mean by free will.
Okay. So the ability to pick out what variables you consider and what variables you ditch and how many you should consider to make this decision.
Yeah.
That counts as free will.
Yeah, like maybe I won't chase the deer this time
Right.
because maybe there's something bigger than me that's
Uh-huh.
approaching.
Right.
Something like that.
No, yeah, that's a very good definition.
So, as we have concluded, free will and consciousness are intertwined
Yes.
in each
very
other.
much.
You can't disregard one without sacrificing the other.
True.
So, let's look at some free will experiments. Now, obviously, just like with consciousness, scientists were interested in understanding free will with regards to neuroscience, in coming from a neuroscientific point of view. And what they, so we all know about seizures, right? What they do. So when someone goes through a seizure, they start to do things in a very erratic way. So they might start ticking, or if the seizure is really severe, then they'll fall to the ground and they'll start shaking. Now, there was this one particular scientist called Wilder Penfield. He was a neuroscientist, a neurosurgeon too. And he asked the question, why aren't there any intellectual seizures? So, if someone gets a seizure, why don't they erratically start doing calculus in their mind or math?
So why are there no useful seizures?
Yeah. Or maybe detrimental seizures in an intellectual way. Because maybe you don't want to do math at this particular point of time, but because of a seizure, you start doing it. But I've never heard of this. I mean, if anyone has, please let us know. Yeah.
Yeah.
If you've had any intellectual seizures, you just started doing math in the chemistry class. So, along with things like maybe politics, like seizures don't cause you to randomly think about politics or moral reasoning, what is right and wrong. So these seizures only seem to be affecting you physically.
Yeah, physical.
But if higher order thinking, things like politics, religion, maths, all of these things originate from the brain, or the mechanisms by which we do these things are in the brain, then the seizures should also cause dysfunctioning in intellectual phenomena, right? Intellectual seizures should happen, but they don't.
Yeah, but like you can even argue with the point that physical seizures have like a physical movement or something which you can see, right? Yeah, but like intellectual seizures, like there's no physical aspect. So how do you know if you're having one or if you're not having one? What if I regard a yawn as an intellectual seizure? But
yeah,
it's
that's a
just
physical response.
Yeah, it's a physical response, fine. But if something which doesn't have a physical response, which just happens in your brain, how would you categorize it as an intellectual seizure?
You would experience it. So I can ask you, did you ever have any intellectual seizures?
Right, like someone that's had a seizure remembers the seizure that they went through, right? So they'd be able to recount whether or not they just randomly started doing calculus in their head when they had a seizure.
And that would be pretty groundbreaking, because I've never heard of that.
Yeah, man who solves the Fields wins the Fields medal because of a seizure.
Yeah.
So I think, wait, do you know the exact cause behind how a seizure works? Like a general.
Well, I think obviously it has to do with when all the neurons suddenly activate. And so maybe there are scripts in your brain that only activate when you lift your arm up.
True.
But because of the seizure, that script activates, that particular string of neurons activate.
Wait, so people that go through seizures still are conscious of what's happening to them, right? Like
They
the
are,
fact that
they
they're going
are.
through tics and stuff.
Unless it's really severe and they pass out.
Right. So, I mean, if they're completely conscious about what's going on, then it's not like a seizure affects your thought process, right? But it should.
But it should.
Point. Oh, right. Because technically everything's in the brain, so it should
Yeah.
just end up messing with your head.
Exactly.
Right.
And one more thing. You know how if you open up the skull,
Uh-huh.
the brain doesn't feel pain.
Oh,
Yeah, it doesn't. The brain doesn't have pain nerves. You know,
On the skull?
not on the skull. If you expose the skull,
And
let's
when you
say,
start touching the brain.
you start touching the brain, the person wouldn't feel that.
Okay.
And so what Penfield did, Wilder Penfield, what he did was he opened up a bunch of patient skulls, and he started prodding the brain with electrodes.
Okay. Wait. So when you say that they don't feel pain by touching the brain, how is the process done? So when you take when you remove someone's skull so you can touch
Well,
their
you give a
brain,
local anesthesia before you remove that part of the skull.
and you can be certain that the local anesthesia doesn't affect whether or not you feel. So they don't feel people touching their brain itself?
Yeah, there are no
Oh.
nerves on the
Right.
brain. They don't have space for that.
Yeah,
And they never
like-
thought about.
Yeah, like there wouldn't be any use for a nerve which will go from the brain to the brain, you know? It's
Yeah.
from the arms to the brain so that you feel something touching your arms like that.
And if you feel something touching your brain, at that point, what can you do?
So where are we going with this?
Yeah. So what Wilder did was he took these electrodes and he started prodding certain parts of the brain. So, and he asked the patient, "What do you feel?" And for example, he found that if you prod, let's say, the back of the brain, then that starts interfering with the vision of the patient.
Okay.
And if you part this particular part of the brain, their arm raises on its own. So he conducted a lot of these experiments to basically see what happens, right? How much can I try to induce using just mechanical means, right? These are physical means. And again, he could never get someone to do calculus by prodding a particular part of the brain. So it's not just seizures that don't partake in intellectual phenomena, but you can't really, you can get them to raise an arm, maybe feel ticklish, any physical response. You could, even theoretically with enough electrodes and all this stuff, you could maybe get them to walk on their own. Yeah.
Okay, so brain has like this security system where you can hack into the work of a brain, but not the brain itself. Suppose if the work of the brain is to move your leg, you can hack into the brain to move the leg, but you can't hack into the brain to do the brain's function, like think by yourself, write a poem, do a painting, something like that. Like there are two layers to it. The outer layer would be the physical stuff, where you can like induce impulses and be like, oh, move that, but you can't go to the deeper level of inducing self-thought or drawing or calculus or something like that. So
But
basically-
even the deeper level,
no, by deeper level I mean like there's a security system for the brain. Like it lets you to access the muscles, nerves, and all, but it doesn't let you to mess up with the the more again deeper aspect of the brain. Like self-thought, calculus.
So I think the point you're trying to make is that neurons, and when you prod the brain, going by the security system logic, you can hack your responses to things. As in, so the response would be to move a leg, would be to paint a particular way, but you can't hack into the logic that produces those responses.
Pretty much.
Okay.
yeah, sort of. But the deeper level that you speak of does not seem to reside in the neurons in the brain, or even their arrangement.
Or one of those matters, the gray matter, white matters.
Yeah, it doesn't reside in that. It doesn't seem to, based on these experiments, it doesn't seem to reside in that matter. Hard-coded into the brain. If you assume the brain is a computer.
So I think the next question would be, what's the origin of?
Yeah, we'll come to that later.
Yeah, so that
Yeah,
if you want,
it's-
like we know the origin of muscle movement is that location, so we can manipulate that. So the next big question would be the origin of calculus in our head.
Well, that's one of the easy problems of
What? Okay,
consciousness.
I was about to say, that's one of the leading research where we're going to put $2 trillion and we'll waste your money. Okay, anyway.
And and that's an easy problem. That's
Okay.
what they haven't solved this yet, but they say that's the easy problem. So there is also a hard problem, which is pretty much impossible. So what is the easy problem and hard problem? Consciousness. So the easy problems are things like Shreyas just said, like figuring out
The
say,
physical location where.
the physical location of, where calculus happens or something like that. Or let's say determining, things of that nature. Now, coming to the hard problem. Now, let me ask you this, Shreyas. Do you know what it's like to be a bat?
To be a bat.
Yeah.
I could imagine it.
But would you ever be able to obtain that information like how you obtain the information for a particular scientific theory?
Okay, no.
No. So that precisely is the hard problem of consciousness. So there's this novel by Philip K. Dick. It's called Do Androids Dream of Electric Sheep? So the title is alluding to the hard problem of
What was
consciousness.
the title again? Do androids?
Do androids dream of electric sheep?
Nice.
So, by the way, that book is what Blade Runner is based on. The movie.
Oh, really?
Yeah.
Ooh, fun facts by Aniket.
Yeah.
Okay.
So, to answer those kind of questions, all right, it's not about a matter of time, really, but a matter of perspective. I mean, how would you, given enough time, given infinite time, let's say I want to know, Shreyas, what do you mean when you say that you see the color red? So, for example, what do you think is the color of this wall?
Cream.
Is there any way that I can know?
Okay, so
that
basically.
what you mean by cream is what I think I mean by cream.
Okay, so you're telling me to explain color to a blind person.
Sort of, but even I can see color.
Okay.
In fact, it would be harder to explain what you're seeing as a color to a person who can see colors.
Than to a guy who can't see colors.
Because at least he doesn't have a point of view
Oh, okay.
from which he can compare, okay, you're seeing this, what do I see? He'll be fine. So you see this. The thing is, you can't even describe. So how would you describe the color red?
To you,
Yeah.
I would say, hey, look at this Rubik's Cube. Okay, this doesn't have any red in it. Yeah, this cable, probably.
Yeah, but the thing is, you have to sort of rely.
Yeah, we
on-
have to rely on, secondary. Look at that, that's red, like that.
on the assumption that I also know.
Yeah.
What do you mean by color red?
Yeah, so, there's no like formula. Or we could put it in a formula, right? Like, look, I'll put light on this, and the wavelength which we get back, if that's red, it's red.
Ah, you see, but now you're labeling wavelengths.
Yeah, so I'm giving it a mathematical form.
Yeah, but you're labeling the wavelengths now.
Yeah.
Okay, but imagine this. What if for the same wavelengths, the color red looked like the color blue?
What if for the
If you
same
if you
wavelength?
switched the colors so that now colors of the wavelength red look like the color blue to you, and the colors of the wavelength blue look like the color red.
Okay, now this can be solved by keeping a standardized like how we use SI units, right? So we just standardize it. We just like, no, this is red, this is blue, this is green.
Okay, so I think the point you're trying to make is when I see a light ray coming of the wavelength that red is produced of, my brain perceives that a particular way.
Yeah.
And so now I know that that's red. Same way, since you can see, when you look at, by the way, a gigantic ableism where super sight involved, but when you look at red cable, you can tell by the light that's reflecting on it and coming back into your head that this is red. But what you're trying to say is that you won't be able to know the exact way that my brain perceives red. Is that what you're trying to get at?
Not in a sense of a mechanism.
Okay.
I just mean
The
Can
way
you-
the way your brain considers red to be tangible? Like
no.
then? Okay.
How you consider red to be tangible.
Right,
not the
exactly.
brain. So if I ask you to
Okay, if we
describe,
both see the same cable, so this the red I'm seeing is my red
Yes.
in some sense, and the red you're seeing is your red.
Yeah, and the most important question is
How
if
do
those
I
two
communicate?
reds are different.
Okay.
How would you figure out if they were different? I mean, there could be slight variation,
Okay.
but I won't be able to tell it to you, if, let's say, tomorrow the colors were swapped, the wavelengths would still remain the same, all right? We would still have, we could still use the colors as they are. It's just that now to obtain the color red, you have to go to different sources. To obtain the color blue, you have to go to different source. But that warm feeling that you get when you see that wavelength, that warm feeling is, it's like you're staring at the sun. That warmness, if I were to take it and visualize it, I think that would be the color red. Yeah. But even a statement like that, if I say it to you, does the color red pop into your mind?
No, because for me, when you say warm wave, warm bright light and stuff, I think of yellow or white.
Exactly.
Yeah.
And so that is one of the hard
So
problems.
that's the hard question.
That's the hard problem. But that's one of the hard problems.
Okay. Is that like we don't have a solution for it because would like our communication be a key aspect in why we don't have this solution yet? Like we communicate in a very lower level probably.
Well, if you think of it from a fundamental...
Wait, is it a? I don't think it's a communication problem. I think it's a logic problem.
We don't even know if it's a logic problem.
Okay.
Because if I were to give you infinite time and the best technology that there is, yeah, let's take this particular thought experiment. So there's this scientist called Mary, and she's working in a room. And the thing is, the room...
Don't keep moving it.
Okay.
It'll keep changing. Yeah.
Fine. So the thing is, the room, she's trying to figure out information about sounds. Okay. And the thing is, the room is completely quiet, and so she spends quite a while with the best tech possible to learn everything that you can know about sound. But the thing is, she's never heard sound personally. She's never heard it, but she's read all the textbooks, all the case studies that are conducted. Let's say that they even invent a sort of communication system that is the most efficient at delivering subjective experience. So if someone wanted to describe the sound of a snap, let's say that they invent a new language for that, because as you suggested, maybe this is a communication problem. Maybe our language isn't suited to describe subjective phenomena. Let's say they even had a language to describe what this sound was. Let's say she knows all of this, she learns all of this, okay? And then she steps outside the room and someone honks a bell near her. Would she have learned something new about sound that she didn't know before?
She would then learn the context in which that sound shows up, right? Like, for example, a car honk would indicate that there is a car somewhere to your side, right?
But she would already know that. Like, I'm saying every information that you can know. I mean, even like, okay, so we have this particular wavelength, or when you're doing audio mixing, you have these graphs and all that show up for different sounds, right? Let's say that she knew everything about every single sound ever, okay? And then she stepped outside.
Yeah, I think the answer to that would be no.
So
Because the question had infinite time and she wanted to learn everything. Yeah. So when she listens to a car honk, she doesn't learn anything new.
But thing is, she's never heard anything before she stepped out of the room.
Yeah, but one of the things your brain can do is, suppose like you don't solve any question, but you by heart the formulas and you go to a test. You can, if you're lucky, you can solve a problem related to that formulas which you learned.
But
It's one of those things, right?
The application, because the formula is objective. So any person, any point of time, can use that formula and get the answer always.
Okay.
But I'm talking about when you hear, when you hear the sound of a honk.
Okay.
That
yeah,
is something.
no.
That
I think the answer to that would be no, because sound, for example, like how a newborn baby learns is through experience. Like it hears this is his mother. It hears this, so this is dad. It hears this often, so this is his name. It's just on past experiences.
Well, no, I'm not talking about context either. You mentioned context, but I'm not talking about the context either. I'm just saying that sound, the sound that sound makes when it's produced. The thing that happens
Okay,
that you perceive.
so she knows the whole physics behind the sound, but she
Yeah.
doesn't know that sound.
She doesn't know what it's like to hear a sound.
Yeah,
That's the point
Okay,
of the experiment.
fine. So where are we going with this?
So now, obviously, from a very intuitive standpoint, from our own experience, you would think that once she hears something for the first time, she would learn a new experience, right? It would be
Yeah, that's an experience.
Yeah.
To
Now, do you consider the experience to be information?
yes, I think that's like the most important information in human experience,
Exactly.
in human
Right.
learning process,
But
because you refer back to that, and then you'll be like, if you listen to a bicon, you'll be like, wait, let me refer to the database I have. Oh, this is not that. So it's not a bicon. It's a new new element. So let's save it here. Like that.
yeah, but the premise of the experiment was that she knows everything there is to know about sound.
Okay, so that experiment would be only complete if she hears sound.
Yeah, and so
So that's a requirement of that experiment to be successful,
yeah,
is that she experiences all the sounds.
yeah, and so remember how you were saying that if we you were saying that it's very complex, right? So what you're doing is you're pushing the problem into complexity. So you're saying it's a problem of complexity, not of nature.
Okay.
The thing is, no matter how complicated it is, the problem that she's trying to solve inside the lab, the problem of trying to experience hearing without experiencing it is not a problem of complication. It's a problem of fundamental nature, is that she hasn't experienced sound.
Like this goes back to the question that you brought up about consciousness, right? Or free will, which is that, like again, since you don't know exactly where these particular neurons are firing from, normally how I would consider sound or that particular experience is your sound hits your eardrum, that gets passed as an electrical impulse into the part of your brain that processes logic, which is the part that we don't know, that doesn't exist in the neurons, and then that gives an other signal to a bunch of other neurons that either runs away from the particular car honk or moves aside. So what you're saying is that since we straight up don't know what is processing that logic and what consciousness is, that regardless of whether or not she knows everything there is to know about that particular sound, its wavelength, like even if she knows like the particular Fourier transform of every single sound and the context of everything, that she still would not have been able to experience that sound because of the fact that the way we have a particular, we're assuming that the scientist is deaf, right? Is this a...
No, but that, let's just say for the sake of the experiment, that she lived in the room itself.
So she was born in the room, okay.
I mean, yeah.
Fine,
I'm just
let's go with
assuming.
that, as an assumption.
Yeah.
Fine. So that she did all her research inside this room. Okay, so I think that basically means that, for example, now since her, not an example, but since her entire experience with sound has been inside this particular room, for example, if I hear a car horn on the road, I will jump and I will move away to the side. So a part of the information my brain holds on that sound also holds this sense of urgency for me to move to the side. Like for example, if I had a car horn without the car, I would still jump to this side because like that's just how my brain is going to react. But since she hasn't had that context, because she couldn't have
The
given that
experience.
context. Exactly, she hasn't had that experience with that particular sound. The way she perceives it is going to be very different from the way we perceive it, right?
And so that's a lack of knowledge
Right.
on her part, right?
True.
So that's what basically I was trying to illustrate.
Yeah. So to fast forward it, it's a default in the fundamental. It's not default in logic or communication or something like that.
It's not a complexity problem.
Yeah. It's not. It's just defying
It's a
the
very
fundamentals.
fundamental. It's a very fundamental problem.
Yes.
So next, there was this neuroscientist called Adrian Mark Owen. He used to study patients who were in a persistent vegetative state. So, do you know what that means?
Does it mean like one of those Captain America Winter Soldiers frozen bottle
Yeah,
Russian experiments?
exactly.
Okay.
But if you try to see what's going on inside, there's nothing there. That's what neurosurgeons, doctors.
Okay, so you're
and
telling
even
me there are no
scientists.
there are no brain signals in the
There's no
vegetative-
brain activity.
So what's the difference between him being dead and alive?
Well, there was the bare essential.
Okay,
Sort
like,
of like
you know,
Captain
like
America.
breathing, heartbeat, stuff like that.
Yeah, things like that.
Okay.
But things like making choices and all this, that was simply beyond the
Making
scope.
choices. I'm pretty sure no one will choose to be in a vegetative
Yeah,
state, but
like that
anyway.
is beyond the scope of what scientists thought a person could do in a persistent vegetative state.
Okay.
Or that people would wake up 20 years later and this, where am I? How did I come here? So what this guy, Adrian, what he found out was, so a lot of the family members of the patients, they used to say things like, he really still feels as if he's there. These kind of vague statements about familiarity, even with an unconscious body. And that's where it started. But what he found out was that if you say a sentence to the person lying on the bed, and you see the MRI scan, so what they do is they take these nodes and they stick it to different parts of the skull, and they see the MRI activity that's going on,
do they respond?
and they responded.
Okay.
So initially, what he assumed was that this is reverb.
This
So
is what?
Reverb.
Okay.
So the sound that's going in
Huh?
is coming back as activity, like an echo, almost like an echo.
Okay. So
right?
there's no like processing. There's no
Processing, yes. So he assumed there was no processing. And what he did is that he took a conscious person. He took many conscious people, many vegetative people, and he said the same sentence and he recorded their MRI scans. And then he showed them to his colleagues. And he said, can you recognize which one is the conscious and which one is the vegetative one? And they couldn't tell. The exact same kind of response was being given in both. The same kind of lighting up in the scans, in the MRI scans, was happening. So what he initially assumed was that, okay, this might be a reverb. And since a reverb can happen for both a vegetative person and a conscious person, so maybe that's what it is. But here's what he did next. So he took the sentence, let's say, for example, Shreyas likes jogging.
Okay.
And he said, jogging like Shreyas.
Okay.
The level of activity drastically reduced when the
Wait.
meaning was taken out of the sentence.
Okay. So the person understood. There's an aspect of understanding.
Processing, like we said
Processing.
before.
Yeah. Processing.
So, and he did that for the conscious people, and obviously they also responded the same way. If you told them a sentence that doesn't make sense, there'll be less activity, less understanding.
Yeah.
And again,
There'll be
so
more activity.
less activity. Because
No,
they
wouldn't there
understand.
be more activity? There'll be like no. If you tell something that's wrong,
Okay, they're trying to figure out why it's
yeah.
wrong.
So there'll be more activity in the brain.
Okay, no. What I mean is recognizing something familiar. In that sense, there was less activity.
Okay.
That's what they interpret.
Mhm.
Like the scientists, they interpret it that there's less familiarity with the sentence. So less meaning, less processing. And so this was really groundbreaking because that definitely means that they are recognizing the sentences being spoken through their ears.
So the next question is, what is vegetative state then?
Exactly. I mean, just because the brain is so impaired that they can't open their eyes, they can't do all these normal things, all right? The brain is so, it's so destroyed. When usually people who end up in vegetative states do end up because of accidents and stuff like that.
Yeah, like in a coma and stuff like those.
And so it's destroyed to such an extent that they're in a vegetative state. They're like a vegetable. That's where it comes from, vegetative, vegetable. But the thing is that higher order thinking, like, for example, choice making. If you give them two choices, for example, if you ask them to say the number 6, all right, and you give them, like you tell them, like the questioning was framed in such a way that the scientist would say different numbers, all right, and then he told them a number, and so they had to like that's what they tried doing was they had to point out that number was being spoken.
Yeah, so there's a back and forth. Like I'm telling you something and I want something from you.
Yes. So let's say the number was 6, and he goes on 10, 21, 5, 16, 6. As soon as he said 6, there was a spike in activity in the MRI scans.
Okay.
And so they were even communicating while in the vegetative state. When they couldn't move their hands, they couldn't move their eyes. There's basically no higher order activity in the brain. They could do all this stuff. When the brain is so damaged, they could still do this stuff that we expect from a mind. Yeah, and it still worked. That also happened. Yes, they could do basic stuff. Things that require pen and paper.
Yeah, so the point is?
That even though the brain is so dysfunctional that they're in a vegetative state, the mind is still very capable of doing things.
You told two different words. You told the brain and the mind.
Yes.
So what do you mean by the brain and the mind?
Well, the mind is, going back to
was that like a general phrase? Or
No.
do you consider mind as a separate thing from the brain?
Well, that's what everyone considers, right? The mind is basically, if you were to give a sort of intellectual organ.
Oh, that would be the
that
mind
would be
then.
the mind.
Okay.
The physical organ would be the brain.
Okay,
like,
okay. I get it.
Like the hardware and the software of a computer. So the brain is the CPU, but the code, that's the mind. That's what the general analogy goes.
Are you done with the topic?
Yep.
Give the mic to pause it. Or just... Oh, I know you guys are dying to hear more, but this is where the first part of the episode ends.
Yep.
Thank you, Aniket, for having this, for doing this with us. And we would like to do this as a series.
Yeah. So Aniket has a lot more to say with regards
Oh,
to
we
this
have a
topic.
tons of content. Content
Yeah.
is not a problem.
We had like a 19-page script. We're 2 pages in and we're like an hour in worth of recording.
Yeah. So I think this would be the end of the first part of the Aniket series.
Yeah.
And it was some hardcore stuff, man.
That was very hard.
Some 3 electronics engineers discussing about neuroscience.
Right.
Why wouldn't you listen to us?
Yeah, we're so well versed in this subject. No, but I think I do really think that our perspectives are pretty logical in a sense.
Yeah, and the one thing I would take back from our interaction would be the human brain is super complex.
Yeah.
I mean, it sounds very dumb, but I mean, it sounds like, everyone knows this. But I just became more aware of the fact that, it's super complex, and all these neurosurgeons with 30, 40 years of experience, they do know more than, they do know more relative to us, but they don't know the brain.
Yeah, we pretty much just got to know how much we don't know.
Exactly. On that note, thank you for your patient listening. You can follow us on YouTube, Instagram,
Spotify mainly.
Spotify, Amazon Prime.
Yeah.
Thank you. Bye-bye.
Alright, bye-bye.